Welcome to another video on Android CICD series. In the previous video, we have seen how to actually split a CICD file into separate custom CICDs, which are going to solve very specific problems, which is PR merge, PR analysis, and actual release. And as a part of the release, we also saw how the secret signing was happening in that particular CI/CD. If you have done Android development and you want to basically put this particular application or APK file on emulator or on device, then signing that particular APK file is very, very critical. It looks like a very mechanical step, but you need to understand what it means to sign an APK. What is a digital signature, what is a key store file, what is a secret key, what is a password, all those things. If you already know all these things and how they all come together to actually sign a APK file and what it means to sign an APK file, you can just drop this particular episode. If not, then let's go through this particular episode where I basically break this down and explain all the nuances. So broadly speaking, Android signing is not just a simple Gradle block in your application. You have to understand that the debug builds are signed so that the developers can install them quickly, and release builds are signed so that Android App Store can recognize the update identity or developer identity. So debug signing is for the convenience of the developers, and the release signing is the identity and update continuity. That is the reason why if you lose the access to the digital signature, then basically you lose the ability to update a app that you might have already put on the App Store or Play Store. So in this video, we will basically go through three things. That is what it means to sign an application using the debug key, how auto signing happens, what does a key store container actually contains, and then we understand how the actual signing logical order happens. Let's talk about the debug APK signing that happens automatically. Technically speaking, it just involves these couple of steps. That is, when you hit a Gradle W assemble QA free debug, which is one of the build variant that we want to build, then AGP resolves the variant. So it understands that we are trying to build a debug variant. Then it builds the APK file, and then AGP automatically applies the debug signing. What do I mean by debug signing? The Android system automatically provides a debug key store file which contains the passwords, aliases, everything, and using that it automatically signs that particular APK file, and this you can install on a emulator or on device. If you want to install it on a device, then you have to enable debug in the device. Otherwise, you won't be able to install an APK file which is assigned with a debug key. So let me show you what exactly this means. This is my Android folder, and here if you see, there is this debug.keystore file. It is this keystore file that is being used to actually sign a APK file. For example, this is our application. We have seen it from the very beginning of this particular series, and there are multiple build variants that we are building here. And let's assume that you select QA paid debug or QA free debug, and then when you click on this particular run, it basically creates a APK file. You can actually see where that particular APK file is created. If you go down to the app build outputs, you can see that there is this APK, and under this APK, you can see various folders are there. For example, if you see here under QA free, there is a debug, and this particular APK file app-qa-free-debug is the one that got created when we had ran it last time. There are various ways to install it. One way is you can simply drag and drop this on the emulator, and automatically you can see that the application is getting already installed on the emulator. There is even another way you can do it by using a adb command. That would look something like this. Let me open the terminal. Say I can write adb install and then the path where your APK file is. and then hit enter, and once again that will install the application, and you can see that it is once again installed. So this is pretty simple, but what we are talking about here is only about debug, but that's not the only thing that we are dealing with. If you are planning to sign it with an actual APK file, then you need to understand what is key store file, what is store password, what is key alias, and key password. To get a mental model of what these things are, because if you look at the build Gradle file, you will find them mentioned in the signing config. In the signing config, you might have seen these statements like store file, store password, key alias, and key password. It is this signing config that gets applied to the release build type so that it gets signed with these configurations. And where are these keys defined? In the local.properties file when I'm trying to sign it locally from my machine. I want to basically walk you through now what all of these things basically mean. What does this .jks file mean? What does it contain? To understand that, you have to understand store file is like nothing but a vault. It is a file which basically contains two things, that is path to the key store on the disk, that is where the key is there, that is the key store file. Think of key store file as like a envelope containing the actual signing key, but that envelope itself will have to be properly password protected. So for that particular key store file, usually which is a .jks file or a .p12 extension file, you will have a store password. So the store password that we are talking about is basically the password to the key store file, not the digital key that you will be using to sign the APK file. So this is like a key to the envelope, and inside this envelope, that is inside this particular key store file, you have the actual key entry. So what key entry contains? It basically contains a key alias. Think of it like a name to the key password, and then a private key. This is actually used to sign the APK file or AAB file. Both are one and the same almost technically, which are basically used to apply the application in the App Store. You also have to understand that a key store file can contain actually multiple keys, not just one key. So once you have this particular mental model, you can now understand what does actual signing looks like. Usually you have to first locate the file, that is you need to point to a file containing the key store, then you have to open that, select the key alias, unlock, and then sign the APK using the private key. So it's like locating the key store file and opening that particular key store file to access the key alias and intended key entry, and then unlocking it to actually sign the APK. And it looks pretty similar to what a debug signing would actually look like. Only difference is in the debug signing, most of these things would have got created by the system on the device automatically for the debug convenience. But in this case, it has to be done explicitly. The steps pretty much looks similar to the debug that we had gone through a bit earlier. When you actually try to do it locally on the machine, it looks pretty simple. It doesn't look as complicated as this. I can actually show you. This is the application, and I can go to build, generate signed app bundle or APK, and when you go for APK, it basically asks the same things: the key store path, password, key alias, key password. What we would have given input here, it's the same thing that is happening through a visual user interface. You can try it on your own. That is not my intention to teach here. Now, when you do it with a CICD, it pretty much is same. I can show you that if you go to the GitHub workflows, this is the script that we had written. And if you come here, it is exactly the same thing that we are passing. But where are we passing this particular thing secrets from? It is coming from the GitHub Actions secret. So in this case, that is in the CICD, these protected secrets are coming from the GitHub Actions store that I would have stored them for the security purpose, and then the rest of the flow is still same. You sign it using that keystore file. So that is the reason why I had said when we were writing the CI/CD script last time, PR and the main validation should normally prove the code health without touching the production signing identity. So the script that is actually signing the APK file, that only should have access to these protected secrets. Otherwise, none of the other CIs should have access to these protected secrets. So the mental model that I want you guys to have when it comes to debug build and the release build is debug build is about getting signed with automatic debug store. The password is usually known, typically Android, helps in fast local install and not to be used for the production deployment. But release build is completely different ballgame. It is about explicit key store or upload key. It has protected secrets and passwords. It is a trusted release artifact because it is using that particular trusted artifact that is assigned with the proper digital key. The App Store will allow the app to be either deployed or updated from the App Store, and that is the only way to properly update application. That is the only control update path available from the App Store through that particular secret key, and this is why it matters. So that's it in this particular video. In the next video we will see the next part of, or probably the last part of, Android CI/CD. Thanks. That brings us to the end of this particular video. Don't forget to like, comment, share the video and subscribe to the channel. Take care. Bye.